So here we have thermoelectric generators. That is basically a device that is able to convert a temperature difference into electrical power. And specifically this one is a thermoelectric generators that can be used in our clothes. So it's able to convert the temperature difference between our body and the surrounding environment into electrical power. And this can be connected to some sensors that can be integrated in our textiles. It can be a healthcare sensor that can sensor or monitor a health signal, our heartbeat or pressure or so on. My name is Mariavittoria Craighero, and I am a PhD student here at the Department of Chemistry and Chemical Engineering at Chalmers University of Technology. When I was in the high school, I always liked subjects like maths or chemistry or physics. I have this kind of rational and logic mindset, and I think just those subjects for me were kind of easy compared to other subjects in the high school. So I decided to go in that area, science area. So I decided to join the materials engineering university course, and so I decided to do my master thesis project, this big project during 6 months on this subject. So I just contact few professors around Europe. And at the end, I ended up here in Chalmers at chemistry, in the chemistry department. And then after that, I just continue with the PhD, so here I am. You know, we use textiles every day. And the idea of having textiles and clothes that we can wear with different functionalities, so just not to cover us and to keep us warm, is a very cool idea. Our device in particular is a generator, so it's able to produce electricity and power to then power another device or another sensor. So one use can be to be connected to a sensor that can, for example, monitor our heartbeat, or for example, I don't know, to a GPS, or for example, they can be useful for in textiles. For example, for clothes for workers that they work in dangerous places, like workers and so on. So to continuously monitor their health signals to see if they are safe or not. We work with organic materials that basically are carbon-based materials, and specifically we work with polymers. Polymers are usually known as plastic. But we use a special family of polymers, because when you think about polymers, you think they are insulating, so they cannot conduct electricity. But what the polymers that we are using and we work with are able to conduct electricity if they are treated in a certain way. And also the good part is that they are also carbon-based, so they don't contain any rare metals. So they are made of the most abundant elements in the nature. And basically we use this silk yarn that we then coated with our conductive ink, that is this conducting polymer. And we got these fibers, and these are conductive. Then we use them to sew and to hand stitch manually, the device. And we start by practicing our sewing skills by doing competitions, so we would sew the button in a better way. I had some experience thanks to my grandmother, because during summer I was spending time with her, so then she taught how to sew, but still, like, you know, it's a bit different. So it was like a lot of practicing, and this was also the fun part of this project, because we could also do like sewing. That is something that you don't do in the lab, so it was fun. So this project was part of a collaboration with Linköping University, and a PhD student from Linköping University came here in Chalmers to visit us. and we worked together, and also with Suichi, a researcher in our group. The main challenge was the air stability, and because if we in the future we would like to use these devices in our textiles, they need to be stable in air because we live in the normal atmosphere, so they cannot be sensitive to oxygen or humidity or moisture, so they need to keep their performance for long term. So, and this was not possible before, but now with these fibers, these yarns that we produced, they are very stable, so they can keep their performance for long times. We find challenges every day, especially in the lab. In this project in particular, you try to make something and the yarns were like just sticking together, so it was impossible to use them. So then we had this kind of challenges. I think if these yarns with this material, they might reach the stage where we can really find them in the stores because they are applied in our textiles. I mean, this will be very grateful. I will be very grateful because I did some research on it, and if this can just contribute very little to someone, to the life of someone, it will be. I will be very happy and to contribute to that.